So today we have ABCD, the square of length alpha, where alpha equals a natural number and alpha is greater than 1. There are points such as L1, L2, L3 on BC and M1, M2, M3 on CD. Each segment made by the point measures 1 unit. Then we have to find the value of the expression, this one. So let's start. I have already drawn the figure, and in the question it is given a square of ABCD where L1, L2, L3 are the points on BC and M1, M2, M3 are the points on CD. Now each segment measures 1 unit. So I have written the last limit which is not mentioned in the question. We can see that each side of the square measures alpha. So if each segment made by the point is 1 unit, suppose there are 5 points here and each point measures 1 unit, so it is 1 1 1 1 1 1 1 2 3 4 5 6. So the total length of the line is 6 if we make 5 points. So if the total length of the line is alpha, then we have to make alpha minus 1 points. So I have written the lower limit, the upper limits of the points on each side of the square. So now let us write the expression what is given in the question. It is given sigma from n is equal to 1 to alpha minus 1. And inside of it we get ALN whole square plus LN MN whole square. This one only? Yes. So let us now think of it. First we will think about ALN square. Taking it aside. What it can be? It is actually AL1 square for n starting from 1 plus sigma is there. So AL2 square plus AL3 square. And like this up to AL alpha minus 1 whole square. So now let's see the diagram once. If we carefully observe, this is a right angle triangle because it's a square. Now let us join the points A and L1. It's not joined. Then I will join A1, L2 and subsequently A1, L3, A1, L4, and it will go on up till this one. So one thing what we can see is the AB side is constant and the line joining the points A and all the L's, it is the hypotenuse of that particular right angle triangle. So we can write ALN square as is equal to AB square plus BLN square for that particular n. So we have got the expression of ln square here. Now we will try to solve out that ln mn whole square. I'm erasing this. Now L for n equals to 1, it will connect the L1 and the M1 points. Next it will connect L2 and M2 point, L3 and M3 points, L4 and M4 points, and it will go up till L alpha minus 1 and M alpha minus 1. So like this it will go. So here nothing is a constant as we have got earlier. So let us at first understand the pattern. If we take L1 M1 whole square, then we are actually getting what? This is the full length of BC is alpha minus 1, because up to L1 each segment measures 1 unit. So I am subtracting 1 from the whole side of BC whole square, plus here we are taking this one, so it is 1 unit, so 1 square. So upon putting n equals 1, we are getting the expression L1 M1 whole square is equal to alpha minus 1 whole square plus 1 square. So now depicting it with a general term, that is in the terms of n, we can get alpha minus n whole square plus n square. So we are also getting the term, we are also getting this term. Let us take these two. Here once, and this one, to solve this one. So now let us simplify it till we get the answer. We know that sigma is distributive of addition and subtractions. I'll write the limits finally. Now, what is a ln square? We are getting it as ab square plus b ln square plus ln alpha minus n whole square plus n square. Now let us also describe b ln in the terms of alpha. Now what is b ln? If we take n is equal to 1, then 1 unit, n is equal to 2, then 2 units, n is equal to 3, then 3 units. So it is simply n. So we can write ab square. It is distributive of addition, distributing the sigmas. Alright, so here we are getting a constant. Now I will put the limits, because I will solve from 1 to alpha minus 1, 1 to alpha minus 1, to minus 1. Now we will solve each parts. This is a constant, so it will get multiplied alpha minus 1 times. So the length of AB is alpha, so alpha square alpha minus 1. We have solved this part. N square, we know that the value we get is n plus 1 and 2n plus 1 by 6. I will put n is equal to alpha minus 1 after this, and here it is whole square. So I'll solve this latter. And it is also the same, so we can multiply 2 here. So now let us put the values. Alpha square alpha minus 1 by 3 plus, now we will also distribute it, alpha square plus 2 alpha n minus 2 alpha n plus n square. Again we are getting an n square, so wait, I'll not cut it here only. Let's 6 and 2. We are again getting an n square, so we will add 1 here. So we are getting alpha square alpha minus 1 plus 3n n plus 1 2n plus 1 by 6 plus again alpha square we are getting, so we can add 2 here because it is alpha square only, minus 2 alpha n. 2 alpha is a constant, so it will get outside the sigma, plus now we'll put the values of n as alpha minus 1. Firstly we will get alpha minus 1 into alpha into 2 alpha minus 2 plus 1 by 2. We are cutting 3 and 6, and minus 2n will come outside the sigma, 2 alpha will come outside the sigma, and the sigma of n equals n into n plus 1 by 2. Yes, so we will write 2 alpha square alpha minus 1 plus alpha into alpha minus 1 into 2 alpha minus 1 by 2 minus alpha, we will put n will put alpha minus 1, so it is alpha square into alpha minus 1. 2 and 2 we are cutting, so these two terms are the same. We'll add it, so we'll get alpha square alpha minus 1 plus alpha minus 1 2 alpha minus 1 by 2. Now we will take alpha and alpha minus 1 common, so here we will get alpha plus 2 alpha minus 1 by 2. Here we will also add 2 1. Okay. So half we are taking outside alpha minus 1. Wait. Firstly we can see that here is alpha, here that is alpha, and the 2 is down right here, so we will take 2 LCM and multiply 2 here, so we are getting 4 alpha minus 1. So this one we are getting, let us match the options, 4 alpha minus 1 and alpha minus 1. 4 alpha minus 1 half alpha, so option 3 is correct. Thank you.